As part of past couple of lectures, we have gone through details with respect to joins. We have understood how inner joins are performed and also how outer joins are performed. At the time of exploring inner joins, this is the query which we have come up with. This actually projects order date from orders, then order item product ID and order item subtotal from order items. Now we are supposed to compute daily product revenue using this as reference. When it comes to computing daily product revenue, we are interested only in complete or closed orders when it comes to status of each and every order. First, let us improvise on this query to get only those order details whose status is either in complete or closed. Here we can hit enter. Then we should be able to use where clause. As part of where clause, we can say o dot order underscore status in complete comma closed. This is how we should be able to specify additional conditions on top of join results to get the data based on our requirements. Now, if you run this, we will be getting only those order details whose status is either in complete or closed. Earlier, we have seen 172,198 records when we do not have this where condition after joining orders and order items. Now, we are seeing only 75,408 records. So, these are the orders and order items number of records where the status is either in complete or closed. Now our requirement is to use this to compute daily product revenue. To compute daily product revenue, we need to make sure data is grouped by order date and order item product ID. Either we can specify column names directly like this, or we can also use column position based on select clause. Either you can say group by 1, 2 or group by order date, order item product ID like this. To keep it simple, I'll be using positions rather than hard coding the column names. Once we add these two as part of group by, we'll not be able to project order item subtotal directly like this. We have to just aggregate using appropriate function. In this case, we need to make sure we use sum on top of order item subtotal. Also, as we have seen earlier, when we perform sum, the decimals might go beyond 2 points. To make sure the decimals are rounded to 2 points, we have to use round function. When it comes to round function, it takes two arguments. The first one should be of type numeric. In this case, we need to make sure the revenue is typecasted to numeric using this approach. This is the approach which we can follow in Postgres. Then the second argument is nothing but number of decimal points. In this case, it is nothing but 2. Now we should be able to specify the alias by saying as, then order underscore revenue or revenue. Whatever name you wanted to give, you can give and then take it further. On top of computing daily product revenue, I also wanted to sort the data in ascending order by date and then in descending order by revenue. As order revenue is the third field in a select clause, I should be able to say order by 1 for order date and then 3 for order underscore revenue. As I wanted to sort in descending order, I have to use DESC like this. Now we should be able to select this and run this. It will take care of getting us daily product revenue for complete or closed orders sorted in ascending order by date and then in descending order by order revenue. You can see the output here. You can review the results and see whether for each and every date the data is grouped or not. Also within each and every date whether data is sorted in descending order by order revenue or not. You can confirm by reviewing the results here. This is how we should be able to compute daily product revenue for complete or closed orders by joining orders and order items, then by grouping by order date and order item product ID. Make sure you are fairly comfortable with solutions for problem statements like this.